Okay, so for function notation, it's a mathematical notation that shows one variable depends on another and is a useful shorthand for making statements and asking questions. You'll learn how to express equations in function notations and how to interpret it. So basically, it's just a little bit extra from an equation. So if you take a look there, we've got y equals 2/3 x plus 5. That's an equation. We can put in a value of x and find the value of y. In function notation, we don't use y anymore. We call it a different variable, a different letter. Often it's f for function. Very creative, I know. Sometimes it's G, sometimes it's H. There's certain letters that tend to be used more frequently. If it's an application question, then maybe if it's about height, it's H of X. Or maybe if it's about cost, it's C. Okay, but notice how it is sort of two letters with the second letter in brackets. So here it's F in brackets X. That's function notation because it's telling you the function is in terms of the variable x. And that's all it's telling you, right? And so where it gets to be easier for us is that if I wanted to know the value of the function when x is 10, I don't have to write out, find the value of the function when x equals 10. I can go f bracket 10, and that tells you that you have to put 10 in. So it's a short way of writing out some questions. Okay, and you'll be using it a lot in this next couple of units, and then in Math 20 and either 20-1 or 20-2, both of them, and same in 30. Okay, because it's a faster way of doing some questions. So f of x is so f bracket x is read as f of x. So that's how I always say it. Note that this does not mean f multiplied by x, but rather f is a function of x. So it's a context of a question. Rarely do we use f as an actual independent variable, and so you have to know the context of the particular question. So in question 1, all it's saying is write the following in function notation. So again, we typically don't use y. So I'm going to, for the first one, I'm going to call it f of x, and then I just copy out whatever that's equal to. So I'm just changing y to f of x. That's it. So they're interchangeable. On a graph, if I were to ask to graph f of x equals 300 minus 20x, then I'm graphing y equals. I still call my y-axis y. Here, this is v. So this one, because it's not y, you could use it. It's an application question, right? So that's probably velocity and distance. So that one, oops, I'm going to use v. Oops, sorry. V of d. So v, I kind of do a written v. Okay. And same with h. So really the only ones that we're changing are if it's y equals. Change it to f of x or g of x. All the other ones are representing applications. And so that I change h to h of t. Okay, and it's whatever that variable on the right side is. So that always stays the same. X stays as x, right? D stays as d. T stays as t. Then vice versa here, write the following as an equation in two variables. Oops. So we're going to go back. So this I could use, because it's an application, I could use f equals negative 20t. Here I could just use c equals 20 plus 0.03 d. Just taking away the brackets with the variables. Oh, 24, sorry. Yes, the previous one was 20. And so in question 3, that's where this notation becomes useful. No words needed. In A, it says, it says algebraically determine in A, f of 2. So that means find the value when x equals 2. Don't have to write that out in words. All I do is I go, okay, that's equal to 3. Everywhere there's an x, I'm going to put 2. I'm going to do it in red. So this will be a 2, this will be a 2. I can even put that in red to remind myself. So everywhere there's an x, I'm going to put a 2 in. Now you follow just the order of operations. So 2 squared, you got to do that first, is 4 times 3 is 12, minus 14 plus 2. Okay? What does that work out to be? 0. Okay. So next one, same thing. Everywhere there's an x, I put brackets. And some of you are lazy with brackets. It's kind of okay if it's a positive. If it's a negative, it's going to mess you up at some point, whether it's this question or another. So please put brackets because, for example, when you square a negative, you get a positive. If you didn't have brackets, you would get a negative. So please be careful on that. So that's 16 times 3 is 48 plus 28 plus 2. Okay. And here's what, I'm just going to write, you don't write this down, but if you say you didn't use brackets, this is what it would look like. When there's a negative. And that is a totally different question. That looks to me like 3 minus 4 squared minus 7 minus 4 plus 2. Because you didn't put brackets. Now, if you put the multiplication symbol, then that's okay, but it's really not, certainly here, it's not okay, because that would actually be negative 48. So please put brackets. Just do it for me. And it will help you, because you'll get it right. If you don't put brackets, you may not get it right. Okay, so next one. Different function here. So this is still called f of x, but it's a different f of x. In this case, it's 5x plus 6. So determine f of negative 4. So that's going to be 5 bracket. And then I'm going to put in negative 4 here. And then evaluate that. So really, once you put the numbers in, it's pretty easy stuff. It's order of operations. Notice the difference in B. So this says, algebraically determine x so that f of x equals 85. So that is not saying x is 85. So a lot of students, don't write this down, but a lot of students will go f of 85 equals 5 times 85 plus 6, which is wrong, okay? This says f of x equals 85. So we have to replace f of x with 85. So now 85 is your f of x, and it is equal to 5x plus 6. So I've replaced that entire f of x with 85. Now solve that equation. So bring the 6 over to the left and divide by 5. Leave it as a fraction. It doesn't work out nicely. So what's that? 79 equals 5x. Divide by 5, so x equals 79 over 5. Okay, no decimals. You can't simplify it. Yeah, no, we don't do mixed fractions.
Oh, okay.
You don't have to. Just make sure it's in lowest terms. Once you get to high school, really, you don't use mixed fractions very much. I'm not quite sure why they spend so much time in elementary and junior high on that. Because the fact is, maybe once we get that, I might tell you, oh, now you got to multiply that by another fraction. And really, when it's as a mixed number, you can't multiply easily. You have to convert it to an improper. You can't divide easily. Even adding and subtracting is not good. So leave it as an improper fraction in lowest terms, which it is. 5 doesn't go into 79. So the same thing for the next one. Now f of x is negative 34. So negative 34 equals 5x plus 6. So subtract 6 from both sides. And that's what? Negative 40 equals 5x. So x equals negative 8. I also like having the x on the left. So notice how here, this is negative 40 equals 5x. So you divide both sides by 5. You get negative 8 equals x. It's always better form to have x equals. It's kind of, I always make the analogy is if you're introducing yourself to someone, like I would say, my name is Ms. McKay. Usually I don't say, Miss McKay is my name, right? So my name is Miss McKay, x is negative 8, right? So that's, I'm putting it in a nice order, not negative 8 equals something. It's not wrong if you have it the other way, but this is just proper form. Okay, so those were function notation questions of equations. Now we're going to look at if we have a graph. We still have an equation in this one. It's an application, but it's also been graphed for you. So the height of a ball, h in meters, is given as a function of time, t in seconds. That's the equation. So height is a function of time. The graph is shown. What does h of 2 equals 80 mean? So if you take a look here, you can check it out. When the time is 2, if you go up here, that point, and go across, it's 80. Okay? So that means the height of the ball after 2 seconds is 80 meters. Very fast way of saying that h of 2 equals 80 as opposed to writing it out like I just did. Okay, in B, we're going to use the equation, not the graph. We'll verify with the graph. So h of 3 means we substitute 3 in for all of the t's. So that's 100 minus 9 times 5 is 45 equals 55. Okay. We're just finding the value. You could also put it would end up being meters, right? So I'll put m there. Let's check. If t is 3, if I go up to the graph and across, yep, looks like 55. Okay, then it says use the graph to estimate h of 2.5. So 2.5 would be here. I go up to the graph and across, it looks like it is between 65 and 70, maybe a little closer to 70. So I'd say maybe 68. Okay, so got to do a straight line, and again, that's why having a straight edge will help you out a little bit to find points on the graph. Now let's use the equation. Let's find the exact value. So again, h of 2.5 equals 100 minus 5 times 2.5 squared. I'll just use the blue this time. Now you might need your calculator. 2.5 is 6.25 times 5, so and this is kind of work here, stuff that maybe, I'm not sure what, who's taking science right now? Science 10. Anyone? No one's taking science?
I was second semester. Yeah.
Oh, right.
They always split up social.
Yeah, they try to, but it doesn't always happen. In any case, that's going to be better for you guys, because you're having math first. Sometimes it's better, I guess. It doesn't really matter, but you'll have done this, and this kind of thing you'll do in science sometimes, right? You'll be given a graph, and you'll have to find the values from it. So that's a common thing. So it kind of overlaps into science as well. So take a look. The exact value should be 68.75. Well, that's pretty close. But 68. Pretty hard to tell 0.75 on the graph. But if you said 68 or 69, not 70. So if this was on a test and you said 70, you would be off, right? Because it's not going exactly through that grid crossing. Okay, so they're close. They're not exactly the same. Okay, which is more accurate using the equation. Okay, so now the next one is the height is 20. So it's very similar to these ones back here, question 4B and C, except we have a graph. And so when the height is 20, now you want to go here where the height is 20, go all the way across. That looks like a grid crossing, nice one. And if you go down, it's 4 seconds. Okay. If we were told to do that algebraically, we haven't really done a lot of equations with squared in them, t squared, so probably you wouldn't be asked to do too much with that, although now that we've learned square roots, we could. So, but in this case, we're not asked. But actually, why don't we do it? Let's do it just for fun. So if I put in 20 for h, let's do it because this is a nice number. So let's do it to see. If I put in 20 for h, then I subtract 100 from both sides. I get negative 80 equals negative 5t squared. Then if I divide by negative 5, guys, 80 divided by 5 is 16. So this will be 16 equals t squared. So opposite of squaring is square rooting. What's the square root of 16? 4. So in this case, because it's t squared, t could equal positive or negative 4. Because negative if you put it back in, but we can't have negative time. So in this case, we could do this algebraically. But if you've got the graph, and it's a nice value, just use the graph. Now then it says estimate the range value when the domain value is 3.5. So take a look. Domain value is t. So we go up to the graph again. It's sort of part way between 35 and 40. I'm going to say 38. And then the other is state the domain value when the range is 95. So that one looks easy to see. We go across up the top at 95 and down, it looks like 1 second. So we're just, what we're doing there is sometimes called interpolation or extrapolation. Interpolation is between points. Actually, we didn't do any extrapolation. That would be if we were going beyond the graph to estimate some values, because it's extra. Okay? So, that's using a graph. Okay, now we're going to come up with a graph ourselves. So, told here, this is a really common type of application. So the cost of a banquet is $200 for the hall rental and $15 a guest. So this is really common when you rent the community center across there or any kind of banquet hall. There's always a flat rate, no matter if you have 0 guests. But if you're booking that time, a flat rate is the initial cost, right? And so that's to cover like if they have to clean up afterwards or any kind of wear and tear on the room. Then they usually charge for the number of guests, okay? And so it says write an equation that relates the total cost of the banquet C to the number of guests N. And in part A, it says as an equation in 2 variables. So they've already told us our 2 variables. So we want the cost based on the number of people attending. So who can tell me what that equation might be to get the cost for N guests? Let's get Seth this time. 15N plus 200. Okay, so if there's 0 guests, it's still going to cost you 200. If there's 100 guests, it would be 15 times 100 plus the $200. In function notation, we can use the same C, but it's a function of N. So we're going to have those brackets. Okay. So what variable depends on something else? What depends on what? N is the number of guests. Cost depends on the number of guests, right? So cost depends. So cost is the dependent variable and N is the independent. The more people you have, the more it's going to cost. Okay, so now we're going to fill in a table of values using that equation. So if there's 0 guests, it's still going to cost you $200. If there's 20 guests, then it will be 15 times 20 plus 200. So what's that? 300 plus 200 is 500. Okay, then it would be 15 times 40 plus 200. Okay, so then when N is 40, you put 15 times 40 plus 200 is 800. Oops. So you'll notice it keeps increasing. For each increase of 20, it is increasing in cost by 300. So that would be 1100, that would be 1,400, that would be 1,700. Then you can always check, is the pattern now, the n value jumps. So that's going to be 3,200. Then you plot these. I'm just going to move this because that was in there in advance. And so 0 to 200. We've been nice and we've scaled it for you. 40 to 800. 60 to 1,100. 80 to 1,400. 100 to 17. And 200 to 3,200. Okay, so this is the number of guests. And this is the cost. Okay, so is this discrete or continuous? It is discrete, as you can't have part of a guest. Now, saying that, so we don't join them up, but notice the scale here. If we plotted a point for every particular guest, we would have points all the way along there, which is essentially would make a line. So sometimes we will join them up even if it's discrete, and that way we can answer some questions. So if I move that and get a straight edge and join them up, maybe that will help us with some of our questions. Okay, so that we already determined the cost for 60 guests was 1,100. This can be expressed as in function notation of C of 60 equals 1,100. What does C of 80 mean? That means, oops, here, the cost for 80 guests is 1,400. Fix that a little bit. Okay, what does C of 250 mean? It means the cost for 250 guests. And what is it? Well, we can use the equation. So down here, we'll do C of 250. So we put it in for n into the equation. And we get 33,950. So the cost, I go back, the cost for 250 guests is 3,950. If we have the C of 70, we put 70 in for n. We don't leave a lot of space there, but that's going to be 1,250. And using the graph of the function, so you want to look, we're joining up with a line where C is 70, you go up to the line and then across. Looks like about halfway between 1,000 and 1,500, which would be 1,250. So find the point on the line that has a n value of 70. The cost is 1,250. Okay, and then vice versa, if we wanted to know how many guests we could invite, if we only had $2,000, what would we do? So we would find the point on the line where, now it's not actually y, it's the vertical axis, where the C value is 2,000. Okay, so we go back up here, go across 2,000, and then down, it looks like it's 120. So that is N value of 120. So you fill in that table of values. We've been kind to you and have scaled the axes there on that graph. So once you have done that, then plot those points and label each axis. So in L, it says use the equation C of n equal the equation to determine n if C of n is 2600. So we're going to use the algebraic method, not the graph. So that's not 2600 guess. That would be like a conference or something. That wouldn't be just in a banquet hall. That is our cost value. So then you subtract 200, that would be 2400 equals 15n. So then divide 2400 by 15, and that's 160. Okay, then use your graph to verify that. So 2600 is there across, looks like about there. So my graph is my line is a little bit off to what it should be. I guess if I fix this up, it should be a little bit higher like that. Okay, so it looks to be about 160 guess. Okay, now we're going to do this on our calculator. If you do not have a graphing calculator, move and sit next to someone that has one. Okay, so it says graph this function in your calculator using the same window as the graph shown above. Use your graphing calculator to verify the answers to H, I, K, and L. So I've got a TI and I've got a Casio. So I'll put them on both. If you've got a TI, pay attention right now. Okay, so you go to Y equals, clear off anything that's in there. If there was anything, plots that are selected, stop it. Okay, then deselect it, and we're entering the formula 15x. So your variable is up here, this red, next to the alpha. It's not going to come out as n, even though you see an n there. It's always going to be x plus 200. Okay, if I just go graph right now, it may not have the right window. So we are told to use the window of the graph that's on our paper. And so we go to window, top row, second from the right, it's selected red there. And we need to change this from 0 to 200. So 0, enter, 200. Oh, it skipped, sorry. 0, 200. And notice the scale markings are really going up by tens. Scale doesn't matter on your graphs. It'll just show more tick markings. Then Y min is 0, got it? Y max is what? It goes to 3,500, 3,500, and that goes up by 100ths. Never change the X res or the delta X or anything else, just leave it as is. I don't even really know what it does. 0 to 200, 0 to 3,500. Okay, now press graph, and you should see the graph. Looks the same. The window, copy it out. Okay. Casio. So Casio, we are going to graph. So you cursor in your menu screen, cursor to graph, and enter on that. Just a sec, I gotta make this bigger-ish. There we go. Okay, so I've got to enter on graph. Now, I already have something in there. I'm going to delete that. So you go to delete the formula, and that's F1. So you shouldn't have any equations in there. So if you're using a Casio, you should be following along now. Then you're going to enter 15. Same as a TI, there's a variable button. It's on the left, and oops, that's 15. When I do this on the screen, it doubles up sometimes. Just a sec. Okay, so 15, it'll have an X, theta, and T. So on this one, it's over on the left here, okay? And let me just see if I can get this. View, okay, calculate, okay. Oh, no. I'm just trying to, okay, that's a bit bigger, but that's harder I can't get it all on my screen, so just a sec. I'm gonna go small, small. Okay, keylog, window. Yeah, I don't know how to get it to go up there, but in any case, we're gonna, hopefully you can see the same thing. So the equation 15x plus 200, you have to press execute, EXE, the equals basically, so that your cursor is on the next line if you have a Casio. If it still stays on there, it's not going to graph it. Okay, similar to the TI, you'll see window, V window. So that is shift key F3. Okay, if it's written on the calculator, you have to use the shift key. Then we're going to go, what did we do? We went from 0, enter, 200, enter. Scale we used was 10, enter. Dot, just leave it. Oh, sorry. Cursor rather than enter on that. So I'm going to go back to my window, shift F3, cursor down to Y min. Zero is good. And then Y max, I need to go to 3,500. Go down, scale, I did 100. Okay, and then you're done that. Okay, so exit on that. Oh, it didn't, sorry, what did I say? 100. It didn't, I've got to go enter on that and then exit. Okay, so I'm back to my Y equals. Then you'll see on the very right on the screen it says draw. I want it to draw, and so that means I do F6, that key, and there it is. Okay, so you should have the same graph. So then let's look at what we're asked. So we're asked to do this for part H. So part H asked us, guys, listening. It says use the equation to determine C of 250. We're going to use our graph. So our n value is 250. So on our TI, okay, we are on our graph. Here's what you do for TI. Stop. Do you not have a calculator? A graphing calculator. Well, you should be using it if it's a graphing calculator. So If you press trace key, it goes to a point on the graph. If you just punch in 250, it knows that it's an X value. Enter on that. Sorry. 250. Okay, so what happened when I did that is it gave me an error. Who can tell me why? You have to know these reasons. It was an X that I input, but what's my window? What did I go up to for X in my window? 200. So I need to change my window. See, this is why we're starting this now, because when you get to grade 11, day 1, you're doing this all the time. Okay, and you have to know how to do your window settings. Okay, so we go to window here, and I'm going to go up to 250. Oops, that didn't do it. 250. Enter. Graph it. Now if I go trace 250, enter, it tells me my Y value, 3,950. Okay, and that's what I got. If you take a look at our work there, I got for 250, 3,950 right there. Notice how you can't see the cursor because it's obviously above the graph. So you don't have to have the Y in there, but you have to have the X in the window. Okay, in your Casio, let me just see here. So we're in the graph. You'll see a G solve where you go Shift F5, and actually we didn't even have to do that. So I'm going to go exit out of that. If I go F5, it'll do it automatically. Oh, I guess so. So then I'm going to do the arrow key, and it says Y calc and X calc. This is X. So I'm going to go X calc. Oh, that's Y. Exit on that. Give me a sec. Give me a sec. Just a sec. My calculator. So I'm going to do G solve there. I'm going to do arrow, and there we go. So Y calculating. If I'm trying to calculate Y, I press the Y calc, enter 250. Now, same thing on here. I may need to change my screen. Let's see. Yeah, it tells you, this Casio gives you a little bit more information than a TI. It says out of the domain. Well, we just learned what domain is, the X values, right? So that tells you a little bit more. So we're going to exit on that and go to my window and change to 250. Okay, execute that, exit back, draw it, G-solve, arrow, calculate Y for X is 250, and it tells you what it is, okay? 3,950. So we've done that. Now we've done H, I, C of 70. That's an easy one, same method. So let's do that one. Here I'm in trace, go 70 for X, Y is 1,250. You can see it on your graph. Hope you guys are going to know how to do this if it's on the test.
On a graph?
Yeah. Some of you are doing nothing right now. So then, same thing here, G-solve, arrow, my Y calc when X is 70. Oops, that's 700. Okay, 1,250. Got that. Then we were to do K. So now this is a Y value. This is where the Casios are easier. So if you have a y value, 2,600, I'm going to start with a Casio. That is, you know how we, so I'm going to exit on that. I'm going to draw it again. I'm going to G-solve, arrow, and I'm going to do XCalc, and it's going to prompt you for the y value of 2,600. Okay, gives a x value of 160. Easy. On the TI, it takes a bit more work. So on the TI, you have to, there is no opportunity to find an x value given a y. You have to go to y equals and put in another value. So basically it's another equation. And when you graph that, it's going to be a horizontal line. So now we want where those two intersect. Okay. And so then in a TI, we have to go in calculate, which is second trace, and it will say intersect. So that's what we have to do. And it will prompt you, are you on the first curve, which is the first graph? Yes. So enter on that. And then it'll go, are you on the second curve? It's flashing. Yes. And then guess the answer. Yes, it's a good guess. And there it is. Okay. So TIs are, pardon me? Just y equals 2,600, whatever the y value is. And then you have to do intersect. Okay? So, got to practice those. Heads up. Next one we're going to use our calculator for as well. So a golf ball is hit and its path is defined by that equation. H is the height and D is the horizontal distance. Use your graphing calculator to graph the function and write your window. So in Math 11, you're going to be asked to solve graphically. And when you do that, you're going to have to put in what window you've used. Okay, because we're not going to come around to everyone's calculator and check it during the test or the diploma exam. So you have to tell us what window you used. If you used an incorrect window, then you wouldn't be able to solve it. So it has to be correct. We'll know that if you put something different, you're not getting the right answer, right? You're not using your calculator correctly. So basically it's just taking the vertical format of our x min, x max, and putting it horizontally. So go to your calculator. I'll start with TI again. Go to y equals, clear off whatever you have there. And enter that equation. So it is, h now is going to be y, and then negative 0.004 x squared plus 0.4x. Oh, look at what my calculator, my pen does. Okay, I think that's the same. Okay, so enter on that. And now we have to figure out a window that makes sense. All right, so what I do, so it's a golf ball. First of all, are we going to have a negative height? No. And we're not going to have, well, if I'm playing, maybe have a negative distance behind me because I mess up so badly that it goes backwards. But theoretically, it should go forwards. So I want both my x min and my y min to be 0. Well, they already are from my last one. Okay, who's played golf before? Anyone? Okay, so what's a typical distance for hitting a golf ball? Miles? 200 yards? Ooh, okay. I don't know what this is. Yards is 3, so that's 600 feet. I don't know if this is a good player or bad. I know. Yeah, and this is meters, so, right. So, well, let's put 200 meters because it's close to 200 yards. I don't know if this is a good player or if this is a player like me, right? We'll go 10 as a scale. Again, the scale doesn't matter. Height. Okay. How high? It could go pretty high. Maybe like, I don't know, 50 meters maybe. We can always change it. But if it's going from 0 to 50, I don't need a scale of 100. I'll just do ones, right? Scale is just the little markings that they put on. So really we don't look at that because their calculator is going to give us the information. Graph on that. Oh, okay. First of all, 50 meters is way too high, right? I like to fill up the screen. And 200, this is maybe 100. So this is not like a superstar golfer, let's say. So window, let's go from 0 to 100. And let's go 0 to 20 for Ymax. Okay, that's decent, right? So when I write this out, what did I do? 0 to 100, and I went up by tens. 0 to 20, up by ones, did I do? I think so, yeah. You can always check and just copy it out. Now the Casio is going to be the same. I'll do the same window. So now state the value of H of 40. So I'll do it here on the TI, and then I'll switch for the Casio. So remember, fast way, there are two ways of doing this. You can go trace and cursor along. Problem is, look at all the values there. They're not, I'm close to 40, but I can't get right on 40. So you can't just trace along. So, but if you're in trace and I go 40, then it will go right to that point, 9.6. Okay. Let me just do my Casio. So in my Casio, I'm going to go up and delete that formula. They call it a formula. And then I'm going to enter it, which is negative. Sorry. Oh, what am I doing? I need to be able to see the whole thing. Just a sec. There we go. Okay, so negative 0.004. Nope. For x squared plus 0.4x. Okay. Cursor down. Then go to your window. 0. Oops, sorry. Go to my window. I want 0 to 100. Then scale of 10. Then 0 to 20. And then scale of 1. Okay, now if I exit on that and draw it, there it is. Remember, focus. Then if I go F5, arrow, YCalc for, what was I entering there? What value? 40? Okay, and 9.6. Then do the same for 70. Okay, so now exit on that. Oh, draw, sorry. And then I want to do the same thing for 70. and I get 8.4. Okay, now we're given the H value and we have to get the D value. So now in our Casio, I'll start with Casio this time in this case because it's the easier one right now. So now if I G-solve arrow, I'm going to do XCalc for a height of, what was it, height of 3.6, and it is 10. Okay, then a height of 7, so then I'll do the same thing. And it's 22.6 if I go to the nearest 10th. Okay, in my TI, I go to y equals, I'm going to have to go down and put y2 equals 3.6, graph it, and notice here, this is where you can see something, is that there's two values that have a y value of 3.6. So the TIs kind of prompt you a little bit better for that. And so here I'm going to have to go second trace and intersect, and then first curve enter, second curve enter, third curve enter, and it's 10. Gives me 3.6. Now I need to get the other one on the other side. So I do same thing, second trace, intersect, but now I have to cursor closer to it. Otherwise it'll keep giving me the same one. So if I cursor over the top of it and go enter, 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 I get 90. Okay? And so you can do the same thing for on the TI. Now, back to the Casio, because that was the issue. We only found one here. So to get the other one, we can, I think we just go arrow, and it finds it for you. It's kind of amazing. Okay, so there's the other one that has a Y value of 7, and that is 77.4. Okay, so there's two values for each of them.